in the high-stakes world of air superiority, the next big thing isn't about flying faster or higher. Nope. It's about becoming a totally invisible, all-seen part of a massive network. And today, we're looking at a single piece of tech that's making that future a reality.
Welcome to the Global War Watch Network. Hey, if you want to stay ahead of the curve on all the tech that's shaping global defense, go ahead and hit that subscribe button. It really helps us bring you more breakdowns just like this one. All right, let's get right into it. That quote, it's not an exaggeration, not at all. We're talking about a fundamental change in how stealth aircraft see the world, and, maybe more importantly, how they stay completely hidden. A core piece of technology is being reinvented from the ground up, and honestly, it changes everything. So, what is this big breakthrough? Well, it all boils down to one component that every single advanced aircraft has, but one that's now being totally re-engineered for the sixth-generation fight. The company behind this is General Dynamics Mission Systems, and they've just announced they've developed a new ultra-wideband, or UWB radome. Now, for anyone who doesn't know, the radome is pretty much the nose cone. It's the protective shell that covers a jet's super-sensitive radar and sensor arrays. And this new design, it's a total game changer. And get this is not just a concept on a computer screen. They've already built full-scale prototypes. They've passed the crucial radio frequency tests. Right now, they're pushing to get it ready for full-on production. It's happening. To really appreciate why this is such a big deal, we need to talk about the problem it solves. You see, for decades, aircraft engineers have been stuck with this really tough compromise when it comes to designing radomes for stealth jets. With the old radomes, you had to make a choice. You could have great sensor performance, or you could have a perfect stealthy shape, but you could never have both. They were like a bottleneck, limiting the frequencies your advanced sensors could use. But these new UWB radomes, they completely shatter that compromise. You get way broader frequency performance while keeping the aircraft's stealth shape absolutely perfect. So how in the world did they do it? Let's get into the engineering behind what is, for all intents and purposes, an invisible window for a fighter jet's most important sensors. Here's the main idea. It's a structure made of multiple layers of special, non-conductive composite materials. The real magic is how they've engineered these layers to be completely transparent to a massive range of radio frequencies, all without messing up the signals or, crucially, reflecting enemy radar. Let's break that down. First, you have advanced layering that lets those signals pass right through. Second, the materials themselves are designed to be stealthy. Third, it works with all the different modes of modern sensors, whether it's radar, electronic warfare, or communications. And finally, it's tough as nails, built to handle the insane heat and stress of combat maneuvers. Okay, so we've covered the what and the how. Now for the most important part, the why. Why does this actually matter on the battlefield? Well, it all starts with electronic warfare. This new radome basically uncorks the bottle for a fighter's EW systems. It lets the plane jam enemy radars with way more power, full incoming missiles more effectively, and this is a big one, pick up on those super faint, hard-to-find enemy signals. The radome isn't a filter anymore, it's a perfectly clear window to the world. And this all points to the ultimate goal, right? The main mission for a sixth-gen fighter is to own the sky. And that means finding and tracking advanced stealth jets like Russia's Su-57 and China's J-20 long before they ever see you coming. So by letting the radar operate across a much wider and cleaner spectrum, this tech translates directly into more sensor range, clearer target pictures, and being much harder for the enemy to jam. You see farther, you see clearer, and you are much, much harder to blind. But this isn't just about a single fighter jet, oh no. The impact here is so much broader. This is actually a foundational piece for the entire future of networked, AI-driven air combat. I mean, just imagine the future battle space. You're going to have a manned fighter acting as a quarterback for a whole swarm of AI-driven drones. That requires a constant, massive, uninterrupted flow of data. This UWB radome is the pipeline that makes all that high-speed data sharing possible. And look, this isn't some niche tech for one specific program. It's considered absolutely essential for the Air Force's NGAD, the Navy's F/XX, those CCA drone swarms, high-altitude spy planes, and even next-gen hypersonic missiles. It's a core building block for pretty much everything coming next. So let's pull all this together. What's the big takeaway from this incredible leap in technology? This is not just some small incremental upgrade. The source material calls it a critical enabler. Without this tech, that whole vision of a fully networked, sensor-heavy, AI-connected Air Force, it just doesn't happen. This is the key that unlocks the door to real sixth-generation air power.
And that leaves us with a pretty wild question to think about. When an aircraft's sensors have a perfect, unobstructed view of everything around them, can it change the outcome of a battle before the first shot is even fired? Thank you so much for your time today. If you found this breakdown valuable, the absolute best way to support us is to hit those like and share buttons, and of course, make sure you are subscribed to the Global War Watch Network. We would love to hear what you think about this technology, so definitely drop your thoughts in the comments section below. And you can join the conversation on our social media channels too. All the links for those are waiting for you in the description. Thanks again for tuning in.